So for this lesson, this is lesson 2 in our first unit here, and we kind of talked about how we sort of renumbered what we're doing. We are going to continue with looking at exponents and how do we do operations with numbers that have exponents and kind of the different looks they have and the different things we do with them. And so today it's going to be all about dividing, right? And so whenever we do anything with division in algebra, I think it's just important to note that everything's written as a fraction, because if you haven't heard it before, fractions are division problems, right? And so in algebra, basically since I've been working with students in 7th and 8th grade, I tried to get them away from using that old traditional, division sign, because it's just, it's just problematic, right? And so if we're going to say, 2 divided by 3, in algebra, we would always go 2 over 3, right? And so everything we're looking at today is going to be written in fractional form, and that's what we mean when we talk about division, right? So fractions, basically. So today's learning target is that hopefully after you've watched the videos and everything, you'll be able to simplify some expressions involving exponents and division, right? So again, there's our fractions thing. We'll talk about the quotient of powers property, and we'll talk about power of quotient property, and then the zero exponent property. And so the big thing to remember is when we use the word quotient, right, we are talking about the result of a division problem, right? So, with addition, you have sum. Subtraction, you have difference. With multiplication, right? I'll use the X even though it should be a dot, right? We call those products, and then for division we call them quotients, right? So those are our terms. You got to kind of be familiar with those and comfortable with those by now, so that we all know we're on the same page and what we're talking about. So with that, let's dive in. All right, so the first thing we're going to talk about is quotient of power. So basically, when we are dividing numbers that have exponents and have the same bases, what do we do, all right? And so what it says here is it says to divide two powers with the same base, subtract the exponents. So you'll remember when we were multiplying with the same base, right, we add the exponents. When you divide, it's the opposite. If you can remember that division is like an inverse operation of multiplication, then hopefully you can remember that instead of adding those exponents, we subtract them, right? And so kind of the reason this works, okay, is like this, right? They have this example up here. I'm just going to show you another one with numbers. So let's say that we have 2 to the 5th power divided by 2 to the 2nd power. Now the way this would work, right, is if you take this and we say, okay, we're going to list out 5 2's on top, because that's how you write 2 to the 5th, and we'll list 2 of them on bottom, right? Now, hopefully, at some point, you guys understand, and I think most of you do, that whenever you divide anything by itself, what do you get? Well, you get 1, right? So if I go 2 divided by 2, that gives me 1, right? That gives me 1. And then I have another pair right here, and that it basically will say, oh, they cancel, but it doesn't really cancel. It makes 1, is what it does. But it effectively gets rid of anything on the bottom, right? And because we don't leave that like that. So when you have this, right, it simplifies to 1 times 1 times 2 times 2 times 2 over 1 times 1. Well, who writes 1 times 1 on the bottom of anything? No one. That's who, right? So basically, and who writes 1 times anything on the top? You don't, right? So pretty much it is like it's canceling, right? And so what that leaves you with is 2 to the 3rd, which is the same thing you get if you just say 2 to the 5th, divided by 2 squared is the same as 2 to the 5 minus 2, which is 2 to the 3rd. All right, so it's just a quick kind of shorthand way to get to where you want to go. That's why it works. There's another example here, if that speaks more to you. Excuse me. Other than that, that's it's just a matter of practicing it. All right, so let's give you some practice here. So with anything I do, if you ever want to just pause the video and just try them yourself, go right ahead. The big thing is you can only do these when the bases are the same, right? So like on these examples here, I can't do anything with my H and my G together, right? I'm just going to do G's together. I'm just going to do H's together, all that, okay? So this first one here, we got C 11th over C to the 8th. Now, if I actually wrote this out and I wrote out 11 C's on top and I wrote 8 C's underneath it, right, you would be able to make 8 pairs of C over C, which would equal 1. Anything divided by itself, doesn't matter what it is 1. Okay? And so if you got 8 pairs that you can get rid of, that means everything's going to be gone on the bottom and you're going to have 3 left on top, which again is the same as 11 minus 8. So C to the 11th over C to the 8th is C to the 3rd power, because 11 minus 8 is 3. All right, this one, basically when you do these, think of them as almost 2 different fractions. Think of this, and then think of this. All right, sorry, H squared, right? And so we have G to the 3rd over G. Well, remember, if there's not an exponent, give it 1. All right, write a 1 there. So what's 3 minus 1? Well, it's 2. So we get G squared, and then H to the 5th over H squared. You got 5 up here, 2 down here. So you can make 2 pairs, and you're left with 3. So you get H to the 3rd power. Okay. Oh, sorry, I'm yawning so much here. Now this next one, these are surprisingly tricky for students because they seem to forget that when they're doing division problems that the numbers still follow the rules of what we've learned all these years, right? So you have to think of this as, again, 2 separate problems. Think of this as -2 over 14 times y to the 7th over y to the 5th, all right? And so -2 over 14 simplifies to 1/7, right? And then we're going to have y to the 7th over y to the 5th simplifies to y squared, all right? 7 minus 5 is 2, and it's a positive number, so it stays up here in the numerator. And so the only thing we do is, do you ever leave a 1 as a number? No, you just get rid of it, right? So you would be left with y2 over 7. I forgot my negative sign. Sorry about that. -2 over 14. Here's my negative. So you would have your negative sign here. So you have negative y squared over 7. Okay, so this is how that works. So the numbers, right, the coefficients are always going to still follow the regular rules. Like, so if you have another example, let's say you have 6, x to the 10th over 15 x to the 4th, right? Well, your x's are going to give you x to the 6th power because you do 10 minus 4. And then 6/15ths, right? You just remember, how do I simplify that? Well, the largest thing that goes into both of them is 3, right? And so that would give you 2/5. And so your 2 would go up on top with your x to the 6th, and then your 5th would go on the bottom. So you just basically simplify the fraction part the way you normally would, and then you do what we just, what we're reviewing with working with the exponents. So hope this is helping, and we will see you in the next video.